Dear students, greetings from Dr. T. Senthil Murugan, Associate Professor and Head Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about shell sort techniques. So, in previous video lecture, we have discussed about bubble sort, selection sort, insertion sort, with time complexity of those sorting techniques we have discussed. In continuation of this sorting techniques, the efficiency, we have to improve the efficiency of the insertion sort. For that purpose, we are going to discuss about cell sort. Cell sort is improving the efficiency of the insertion sort. It is one of the type of insertion sort, but it will have some other steps to improve the efficiency. So this cell sort we will discuss in this video lecture. So dear students, this is week 12, lecture 1, classroom discussion topic 34, cell sort techniques. So lecture outcome of this particular lecture is, after completion of this lecture, student will be able to develop a C program, to develop shell sort program to sort the given n elements. If we will give you any elements, you are able to write the program to sort the elements using cell sort techniques with the less time, with more efficiency compared with insertion sort. Okay, so it is considered the generalization of the insertion sort. It overcomes the drawback of insertion sort, what I said in the previous introduction. We'll comparing the elements separated by the gap of several positions. Okay, it is a sorting algorithm that is extended version of the insertion sort. Cell sort has improved the average time complexity of the average time complexity of the insertion sort is order of n square. Okay, so we have to compare n element compared with all other elements. If it is not partially arranged in ascending order or descending order, like that, if we will take that situation, that will be considers the average case. The average case time complexity is order of n squared for insertion sort. For improving this efficiency, we will compare shell sort. So similar like insertion sort, we have to do the comparison. It is also comparison based in place sorting algorithm. Cell sort is efficient for medium sized data set. It is the worth for less size of data set. If it is the data size is more, it is not suitable. Okay. The remaining sorting algorithm like merge sort and quick sort is the more efficiency sorting techniques. These sorting techniques you can learn in design and algorithm or advanced data sector concepts. Okay. So in insertion sort, at a time, elements can be moved ahead by one position only. So we will take the card where it will, which position it is exactly matched. That position we will keep it there. Okay. So the move an element to a far away position, many movements are required that increase the algorithm execution time. But cell sort overcomes this drawback of insertion sort. So what happens? We will take that part, we have to compare with the previous elements. If it is less, we will go up to sorted elements where the position is exactly correct. So left side should be smaller, right side should be the bigger. So in that position, we will insert that part. No, so same position we will discuss in the insertion sort. So for overcome that drawback, we are coming to shell sort. Okay. This algorithm first sorts the elements that are far away from each other. Then it subsequently reduces the gap between them. This gap is called as interval. Okay, how we can perform this using this Knuth's formula. So this Knuth's formula like h equal to h into 3 plus 1. H is the interval having initial value 1. Okay, h is the interval. So the interval period, how much we want, initially we will take h value is 1, then we will increase the 2, 3, 4 like that. So if you will take 1 means 1 into 3, 3, 3 plus 1, 4. So that 4 value will take, each 4 value will compare. Okay. 4 value will take, it will compare with 4th value. First value of the each set of 4, then second value of each set of 4, third value of each set of 4, then fourth value of the each set. So just to see the algorithm that small steps are there, how we can perform this. So we can call the function with the array name and number of elements of the array, that is size of the array. After getting it, we have to calculate the interval. Interval equal to n by 2. So n value, whatever we are getting from that number of elements, that will be divided by 2. So initially we will take 50% of elements. We will compare with the first element of first portion and first element of second portion. The interval should be greater than 0. Then interval divided equal to 2 means interval divided by 2. That will be assigned to interval. Okay. So then each interval it will take interval 2 up to n value I plus 1. It will compare with it will take the first value as temporary value for sorted array. So then j will start with I value. Whatever I value will take, that is interval value that we will take. So interval should be greater than that. Interval j value is greater than that interval as well as j minus I. So example, interval is I value. If you are considered j minus I is greater than temporary value, then you will go for, after performing this operation, you can go for j minus equal to interval. So means j equal to j minus interval. That interval value you can minus, then you will go to do that. So what you have to do, that you have to assign the value a of j minus interval. So interval means, so initially whatever the values are there, we will take that value will take and it will be assigned to a of j. So then temporal is also assigned to a of j. Finally, it will be swapped. You see the example easily you can understand. Now initially how many values are there? This initial array 1, 2, 3, 4, 5, 6, 7, 8 elements are there. N equal to 8. So initially you will take n by 2. N by 2 means, so first 4 elements will take, second 4 elements will be there. So see this example, first 4 elements. That fourth element, up to 4 element, one color they are kept to the blue color with compared with blue color. Okay, so 33 compared with the 12, if it is greater than or less than. If it is less than means the 33 is less than of 12 means we can no need to swap. It is greater than that means we can swap it. So 33 is greater than 12, so we can swap this value. Okay, so 12 will be comes to first place, 33 will goes to fifth place. Then second place value we will take 31 and fifth place value we will take, sorry, sixth place we will take. And second and this place when we are comparing, 17 is lesser value, then it will be swapped. So finally we can compare with 40 and 25. Again swapping is required. 25 will come here, then 40 will go there. Finally 8 and 42, no need of swapping. So after performing this, what will be happen? 12 will comes here. 12 and 17, here 25, here 8, then here 33, 31, then 40, 42 will be there. So this is a final array we will get. Whatever I read, accordingly it is fixed. After fixing this, we will go with again n by 2. So we are used to n equal to n by 2 now. So again it will be divided by 2. So now each 2 if you are dividing, you just see here. All blue colors will be compared, all red colors will be compared. So in this comparison, you just see that 12, 25, 33, 40 is there. Here 17, 18, 31, 42 is there. If you are taking the interval is 2. So in this comparison, after performing this comparison, what will be happen? See here, 12 is there. So after comparison, 12 and 25 will be there, no need of swapping. 25 and 33, no need of swapping. 33 and 40, no need of swapping. So here 17 and 18, so swapping will be there. Okay, so we have to swap it. 8 will become here, 17 will go there. 17 and 31, no comparison. So no, sorry, after comparison, no swapping. So 31 to 42, no swapping. So 8 and 17 only replace it. So 8 and 17 only replaced. So even if now n equal to n by 2, so if now we are consider each element we will take. Okay, so n by n means n by 1 means again it will be 8 elements are there. So each elements it is not sorted. Again we will use this insertion sort techniques which we are discussed in previous lecture. Same concept you have to apply here because it is the overlapping. This is whatever the disadvantages are there. To overcome that problem, we are comes to cell sort now. So after doing this step, directly we can apply the insertion sort to perform the sorting. Okay, so We'll take the final value, then we have to apply the insertion sorting. Each element we have to compare. So left side will be sorted, right side will be take the value and insert in the right position. Okay, so like that, the insertion sort will perform. First we will take 12, 12 and 8 comparison, swapping is there, 8 and 12. Then third value we will compare with previous two, no swapping. Then it will take the fourth value, fourth value compare, so swapping is required, it is swapped. Then this will compare with the previous value, no swapping required. So now 33 is there, 33 will compare with this is the maximum value, no swapping. So 31 is there, 31 will 33, swapping will be there. So 31 will swap compared with these previous values, all are less, so no swapping. So again 40, no swapping is required, again 42 is there, no swapping is required. Okay, so this is improved efficiency in the insertion sort. So what is the term complexity in case best case means n log n concept. So it occurs where there is no sorting required. That means already the values are sorted order. Okay, so there is a best case. Then we can check only half of the elements. So we can perform with n into log n values. 50% of values we are comparing. Okay, so then average case complexity also same thing. It's jumbled with the 50%, but in the worst case is similar that insertion sort also. Space complexity is order of 1, stable is no. Just how many swapping is required, how many division is required, we don't know. So we are using temporary location that we are storing for swapping and doing the remaining operations. So this is a simple program, but we have discussed previously in the algorithm. Same thing we are using the code. So based on that code, it will be swapping. So it will take that initially I value is interval value. What is the interval value? Interval value we are calculated using formula h equal to h into 3 plus 1. We are using so same method we have to apply. Initially h value is 1. You will take that value. That value will be assigned as I. So for example, I equal to 4 means 4 less than 4, then I plus 1, like that it will be there. So it will perform that interval value, then we can apply this for loop. Finally, we can start using insertion sort. So same algorithm we have discussed previously. We can call that function with the shell of a comma n. So a is the entire array, we are passing that. Entire array means the address of the first element, which is pointer pointing to the location, first location of the array. So n is number of elements. So we are forwarding to this function. This function will perform the sorting operation. Okay. So now it's a reflections part. You can find that where the gap is there. What is the gap you have to fill it. Okay. So here this is simple algorithm what we have discussed. In for loop, what it will come? What are the conditions we are checking? Okay. So that we are discussed now. No. So you have to answer it. If you are written the correct answer, we can proceed further, or let's go back and watch the algorithm as well as the program. Then you will come and fill this. Okay. So now you will take 10 seconds time, then you can proceed. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, your time is over. I hope you have written the correct answer. You can check with the answer. If your answer is correct, then we can proceed further. This is the answer for loop j equal to I. J greater than or equal to interval and a of j minus interval is greater than temp value. Then j minus equal to interval. Okay, this is the right condition we have to check here. Okay, so I hope you enjoyed this video. So we have discussed about what is cell chart, how the cell chart is working. With examples, image arrays we are compared with all the elements. How we are performed this cell chart also we are discussed. So finally we are discussed with the program for cell chart also we are discussed. So lecture level problems. Now you will take some n values. That value you can sort using the cell chart technique with the same code what we have discussed previously. So now hope you understood what is cell chart, how it is working. Having completed this discussion on cell chart, now students should be able to write a program to sort n elements using cell chart. Okay, so now you know how cell chart is working, how to write the program for that, how we can sort the elements. So further doubt, you can refer the textbook like classic data sector and reference book data sector through C authored by Rim authorized. So even further doubt if it is there, you come and ask in classroom discussion. Thank you all.